Question 1, challenge.
So press pause, write parts A and B down, press play when you're ready. So this question is about a graphical representation or solution rather to, let's say, a set of simultaneous equations. So it looks different and we basically want to find the answer in terms of drawing the graphs of these equations we'll come to in a second. So let's look at this first of all. We've got x squared plus y squared equals 20.25. So you should know that x squared plus y squared equals r squared. This is the formula for a circle, okay, and this will not be given to you in a formula booklet. One more thing to mention as well, you should know what r stands for. So r stands for the radius, okay, it's quite obvious actually. So r is obviously the radius for this. So if you look at this, x squared plus y squared equals 20.25. It comes pretty self-evident, obviously, that 20.25 represents r squared over here. So let's do the square root of 20.25, and we're going to get 4.5. So basically, 4.5 is our radius, or r. So 4.5, let's look at the graph over here. We have this is roughly 4.5. We have this was 4.5 as well. But here 4.5, 4.5. Let's draw one of our really good, well-designed circles over here. So if I go around 4.5 over here like this, approximately, we're going to get a circle like this. Okay, so it's not exact this, okay, but it's roughly good enough just to make you understand the basic principles behind this. So there we go. Now, hence, find the estimates for the solutions of the simultaneous equations. So you've got a quadratic over here and a linear. Now, guess what? Obviously, question 1, or part 1 rather, looks like part A over here. So this we've already done already. You've already sketched this. Let's now sketch this over here. Okay, so we're going to draw this over here, part 2. So for this one, let's rearrange this. Let's say if we had this 2y equals 3 minus x, because we want to basically get this in the form of y equals mx plus c, and sketch this. Let's now divide everything by 2. So y equals, let's say, 3 minus x over 2. This is the same thing if we rearrange it. Y equals 3 over 2 minus a half x. And let's just write this in the form of minus a half x plus 1.5. It's much easier to see over there. Okay, so we've got y equals minus a half x plus 1.5, which is the same thing as this over here, but we only put it into this form because we can draw anything in y equals mx plus c. Let's get down to this now and draw this. So the y-intercept is first. We look at the 1.5. So 1.5 is roughly 0, 1.5 over here. We then go across and we go to 1, 1. That'll be our second coordinate. And a third one, we go across again. Remember, every one we go across, we go down a half. So this would be 2, a half. So we then draw a line between all three of them. So let's draw a line between all three of them over here. So we have 3 dots. So this again is very, very approximate, but it will do within this video to make you understand the basic principles behind this. And we have 2 values of x and y. So this would be our first one over here. And this would be our second one over here. You can just about see this one, I think. Okay. So these are just estimates, remember. These are estimates. Where they intersect, where they cross over, are our final solutions. So let's do this one first. So this one would be roughly, let's say, minus 3.2, comma, and let's say 3.1. Okay, let's say with that. And this one over here would be roughly, let's say 4.4, comma, it's minus 0.7. So those are our 2 solutions for this. Go through this, make sure you understand. It's all about intersection when you see 2 obviously equations, and you have to draw them both, and therefore they intersect on that basis. Question 2, challenge. So let's now write this down, this cone, and figure out this more challenging question. We want to find out the volume of this cone. This involves a bit of algebra, So let's get on our thinking cap and try to figure this out. It also involves you mixing both the surface area and the volume and trying to mix these concepts to find that V. Anyway, read this question, press pause and press play when we can go through the answers. The diagram shows a solid cone. The diameter of the base of the cone is 16x. We can see this over here. And the height, the vertical height, let's say, is 15x. They both involve x algebra. The total, let's just highlight this with a different color. This is a very important word, in fact, not the curved, but the total surface area of the cone is 800 pi centimeters squared. Excuse me. The volume of the cone is, let's say, v pi centimeters cubed. Find v. Now let's see what we have over here. All right, so literally we want to find out the total surface area of this. The total surface area is what it says over here in green, and it's defined as the curved surface area, which is pi RL. That's given to you, by the way, plus the base, which is a circle, i.e. pi r squared. That's not given to you. That's quite self-explanatory. So let's write this down over here. Total surface area. This is this. It's pi RL plus pi r squared. Now we have the radius. The radius is simply going to be half of 16x, which is 8x. So that's quite easy to find out. This to this would be 8x over here. The question is, how do we find out L? Now L, remember, is this diagonal length, and we always use something called Pythagoras to find this out. This is the bit you want to find out over here. Now here's a bit of a trick, because I think we just found this out. Let's just draw this, in fact, for this. If this is the height, the base, and this is your, let's say, a diagonal bit over here. This height, okay, this height will be 15. It's the same as the height in the middle, obviously. There, 15. 15x, should we say. I'll call it 15x. This is 8x over here. A bit of Pythagoras to work this out would be 15 x squared plus 8x squared. Let's work this out over here. So 15. In fact, we'll just do 15 squared plus 8x. We can add the x's on at the end. This would give us an answer of 225 plus 64, which would give us an answer of 324. If we square root that, we'll get an answer of 17. So this over here, L, would be 17. L would be the square root of 324, which would be 17. Okay, 17x actually. 17x would be that. Right, so let's now look at how we can go with this even further. Total surface area of this cone, pi RL. So pi times r, which is 8x. We'll add the x's now. And this is times L plus pi r squared. So pi times r, which is 8x again, squared. Right, now what do we do with this? We've got to see how we can simplify this. 8 times 17, this using short multiplication, this is a non-calculated question, by the way, is 136. So we have 136 pi x squared, because it's x times x. And we add simply over here, this will be 8x squared. This would be 64 pi x squared. We add these two together, 136 plus 64, because we have the same building blocks, pi x squared, 200 pi x squared. Now this 200 pi x squared is the same as this 800 pi, as we've seen over here. Now 200 pi x squared has got to equal, therefore, what it says in the question, 800 pi. All right, because 800 pi is the total surface area they're telling you. Hence, what has x got to be? So, I mean, 200 pi times 4 gives you 800 pi. Therefore, x has got to be 2, because 2 squared is 4. Therefore, x has got to equal 2. Now, the question is asking for the volume of this cone. The volume is simply going to be a third pi r squared h. And that should be given to you in the formula booklet, actually. Okay, so this is the volume of cone. So actually, we should have written that down in this question. That's what we should have, okay? Now, this is simply plugging the x into here. Now, x is going to be 2. So wherever we have this, x is 2. So let's just see, show you what we mean by this. Pi times, times pi times r squared. Now, r is 8x. X is 2, remember? So this will be 16. The radius of this cone is 16. The height would be 15 times 2, because x is always 2. The height of this cone is 30. So we have that so far. Let's carry on. Now, can we actually, this should be squared. Can we actually simplify this? Now look, a third times 30 would give you 10. This is non-calculator, so we're trying to take any kind of shortcuts we can over here. So it'll be pi times 16 squared, which is 256, times 10. The way we got 10 was obviously 30 divided by 3. 256 times 10 is 2560 pi centimeters cubed. Therefore, V equals 2560. That's the coefficient or the integer in front of that pi. All right, so that is how you do this question. We used a bit of algebra, a bit of Pythagoras, and more importantly, we linked surface area of a cone to the volume by finding out x and plugging that into the volume of a cone.
Question 3, challenge transformations of graphs. So let's look at this question carefully because we have 3 different types of transformations you've just learned within this one question. Try the best you can and press play when you're ready. So the graph shows the graph of y equals a sine bx plus c, and this is called your domain or your input, let's say, of values of x, so between 0 and 360. So let's look at this and see what we can do. We need to find out a, b, and c, these integers over here. How can we do this? Well, first of all, let's remind ourselves how the sine graph looks like. The sine graph as a sketch would look like this. This is something you should know. They won't really give this to you. It starts from 0, 0. It's like a nice wave like this. Okay, and roughly this looks like at 90,1. This is 1 here, this is -1. It's good to know these 4 pivotal points. We call it on math memory. 180, 0. This is 270, -1. And this is 360, 0. Alright, so that's how the sine graph looks like. And from this drawing, you can see that you have a range of y values of, let's say, between 1 and -1, 2. And this interval over here will always be 180 degrees, this wavelength. Okay, so that's what we're picking up already from this. Now let's look at this and compare both these graphs. So we have, first of all, this thing over here showing us 30,3, 153. That doesn't look right because it should be 90,1. So the first thing we're looking at is this 30 over here. All right, now this 30, as we said, the wavelength should be 180 degrees over here. Now, let's look at this and look at 30 over here. This is 30 and this is 90. So why is this 30? Well, we've divided it by 3. So hence the x coordinate has been this x over here in the bracket. This b should be 3 because we are actually shrinking it, or should we say making it more narrow by 3, dividing all x values by 3. So b is definitely 3. There's no specific way we're going to tackle this. It's just the way you see it and compare it initially. That's the way we're doing it. Okay, so that's the first thing we're looking at over here. This is 3 times as narrow, hence it's going to be 3 over here. Now what about this a over here, this a? Let's look at this because we're looking at the length of this, as we said before, and this was 2. Okay, the range. This though, if you look at this is actually 4. 3 take away -1, or the difference, should I say, is 4. Hence, it's twice as big. So that means the y value in front, the a, is more stretched by 2. So a is got to equal 2 here. It's a stretch of 2 on the y-axis. Just like b was a stretch, should we say, of 3 on the x-axis. This is a stretch of 2 on the y-axis. So we're looking at these arrows literally, and this is the best way to do it. Last one is plus c. So c shows you the y-intercept. Over it was 0 at this point over here. Here the whole thing is shifted up by actually 1 if you look at it, because the y-intercept is now 1 over here. If you put a line over here, you can see that this whole thing, that's the middle of it over here, where the middle of it over here was over here. So everything has gone up by 1. And that you can see visually as well, and you can see the y-intercept as well. That really can leave to the end actually, that last y-intercept. It makes more sense. But the key thing is, I look at these 2 arrows over here, the stretches on the y-axis, the x-axis, and to see how you can look at these 2 things first. This one was simply a shift. It wasn't a stretch, a shift on the y-axis, and it pushed everything up at 1. We did that at the end. You can get questions, obviously, where you have reflections with minuses, but that we would deal again at the end of everything you've done. But first of all, deal with these 2 things, A and B, be your stretches first. So A will be 2, B will be 3, C will be 1.